in and of itself, a determinant is useless, but it's used as a tool to solve problems, which we will see on in the next section we do, which will be Cramer's rule, where we will be using determinants to solve problems. Okay, but we have to know how to take a determinant first before we can actually do that. It only works for square matrices. And you can take the determinant of any square matrix of any size. We in here are only going to do 2x2s and 3x3s. Bigger ones can be done. It's a little more of a tedious process, and we're not in the mood this time of year for long, tedious processes. So we're just going to stick with 2x2s and 3x3s. I will show you one 4x4 how it would be done, but we're not going to carry out the process. Okay? Two by two. Very simple. First of all, you have to understand the way a determinant is shown. A determinant of a matrix is symbolized by vertical bars on the outside of the matrix. So far in here, and you can see by this painting on the wall, matrices have had brackets. Okay, like those on the screen. If I want you to take the determinant of the matrix, I eliminate the little tails and we just have the vertical bars. Looks like absolute value. So how do you tell the difference between an absolute value and a determinant? Well, if there's a number inside, it's absolute value. If there's a matrix inside, it's determinant. Okay? So the determinant of a 2x2 matrix, A, B, C, D, just to be general, to find the determinant of this matrix, you simply take AD minus BC. You always start in the upper left and do that diagonal first, AD, multiply those together, and then subtract the other diagonal, BC. So let's look at an example. 3, 5, 2, 1. The determinant of that matrix would be 3 minus 10. So the determinant is -7. So for these three examples, the first one you would go, and you have to be careful, don't get too quick or you're going to make dumb mistakes. And one dumb mistake in these problems leads to disaster. Here we've got 42 minus -8. If you got 34, you made a dumb mistake. 42 minus -8 is chop chop, answer is 50. Second one, you can also make a dumb mistake. 0 times 1 is 0. If you put 1, you made a dumb mistake. Minus 15, -15. Third one, 36 minus 36, 0. Let's try this. See if you can do this all by yourself without me telling you how to do it. Here's what you should have done. Take the determinant, 40 minus -2c equals 26. Chop chop makes it 40 plus 2c equals 26. Subtract the 40, and you end up with -7. Okay. I'm going to show you two ways to take the determinant of a 3x3 matrix. You get to pick the way that you choose to do them. Pick your favorite. I don't care which way you do it. You don't have to ever choose one specific way over the other. If we were going to do larger ones, 4x4s and 5x5s, you would have to use this first method, but we're not doing those, so it doesn't matter. Two methods. The first one is called expansion by minors. Not the guys that dig underground. Minors being minor matrices, and you'll see what I mean in a second. Okay. So I'm going to put a general matrix up there of 9 numbers, A, B, C, D, E, F, G, H, I. And I'm going to show you the process. And I'm going to do this using the top row, but you could use it with any row or any column. It's magical how it works. You don't really need to know that, but I'm just telling you that you could use any row or column. We're going to start with the upper left corner A. And we write down the element A. It's going to be a number when we actually do a problem. And we are going to multiply A by the determinant of the 2 by 2 matrix that is formed when you cross out A's row and column. Okay, so if we cross out A's row and column, and if I do it very lightly so I can keep seeing my letters, you'll see that what is left is E, F, H, I. Do you see it? Okay. Then we are going to subtract. And then we go to B. And we are going to multiply B times the determinant of the 2 by 2 matrix that is formed when you cross out B's row and column. What is that 2 by 2 matrix? Alex? D, F, G, I. Then we are going to move to C. And we are going to multiply C by the determinant of the 2 by 2 matrix that is formed when you cross out C's row and column, which would be D, E, G, H. And that's it. It's minus and then plus. That is why Miss Piggy is painted on the wall over here by my desk. Because it goes minus plus when you're taking the determinant of a 3 by 3 matrix using expansion by minors. We're going to start with the upper left-hand number, which is 1. And the 2 by 2 matrix that is formed when you cross out 1's row and column, which is 8, 2, 5, 6. Minus 3 times the matrix that is formed when you cross out 3's row and column, which is 4, 2, 9, 6. Piggy, 7 times the matrix that is formed when you cross out 7's row and column. 4, 8, 9, 5. Now I want you to see if you can figure out what that equals. Here's what I get. Negative 344. There's all my work. What the heck? That's not right. Negative 344, but that's what you should have gotten. 1 times 38 minus 3 times 6 plus 7 times negative 52. Okay, you can see exactly where your mistake is if you were writing it out and you did not get negative 344. Okay. And what you saw there at the end was I was just showing that you could use the bottom 3 and get the same thing. Like going with the 9, 5, and 6, crossing out those rows and columns, still works. Okay. Why don't you try one all by yourself? There's my setup. Check and see that you set yours up correctly. Miss Piggy. My 2x2s should be -1, 7, 32, giving me -111.